Hi, it's Wayne Scrabba with Lone Wolf Hot Rods. In a past video, we began our look at the brute strength custom 12-bolt rear ends Mark Williams builds. As I pointed out, they're quite likely the strongest street strip iron case 12-bolt rear ends available anywhere. With this segment, we're going to take a close look at the special axles Williams uses in these brute strength 12 bolts. Broken or twisted axles are probably the biggest issue with 12 bolts. Keep in mind the axle is likely the most critical part of the rear end. OEM axles are typically manufactured from 1055 or 1541 steel. Those are carbon steels, not alloy steels. This material is used because of lower cost, but still allows the OEM axles to be induction hardened up to the bearing mount surface. During the hardening process, the core of the axle remains relatively soft, but the surface is very hard, almost brittle. This is a paradox for big power cars with a lot of traction. With the kind of loads an axle sees in a hot rod, there's more to it than just simply the tensile strength of the material. The ductility of the axle shaft plays an important role. The load presented to the axle is so large that it must be able to twist and rebound like a torsion bar instead of being too stiff and ultimately snapping. To achieve the kind of ductility necessary, Williams tells us they employ an Ostempering process with their nickel, chromium, molybdenum alloy high torque axles. This process increases the ductility compared to the ordinary heat treating and oil quench process commonly employed by others. The choice of materials coupled with the Ostempering process provides an axle with an ultimate tensile strength of 225,000 to 253,000 psi along with exceptional ductility. As a heads up, ductility is the ability to change shape or form without breaking. The Ostempering process proves to be far less brittle than an induction hardened carbon steel axle. If all of that is necessary to build good axles, why do you see alloy axles advertised so cheaply? The truth is, they're not alloy axles. These manufacturers produce an axle blank and fly cut the splines, often with excessively long splines. When an axle order comes in, they simply cut off the excess. In contrast, Mark Williams axles are built to the correct length with shorter splines, but still allowing for 100% engagement in the differential. If there's an excess unused spline, then the torsional capability of the axle is reduced. By the way, those other alloy axles have the same heat treatment as stock axles. The only real difference is they are available in shorter lengths and with different splines. Now you know why they're cheap. Speaking of splines, the outer edge of the spline defines the major diameter. The lower portion of the groove within the spline defines the minor diameter. The minor diameter is what determines the strength of the axle shaft. The included angle of the spline or pressure angle is important. Some pressure angles measure 30 degrees, which works out to a 60-degree included angle. But for performance applications, a 45-degree pressure angle or 90-degree angle included angle is superior. The reason is the spline depth is actually shorter, allowing for a larger minor axle diameter on a specific axle outside diameter. Most modern axles are manufactured with a 24 pitch. If an axle has a 1-inch circular pitch diameter, the midpoint between the major and minor diameters, it would have exactly 24 splines or teeth. The distance between the center line of adjacent splines remains constant. So, as the diameter of the axle shaft increases, so does the number of splines. For example, a stock 30-spline 12-bolt axle has a major diameter of 1.291 inches, while a 35-spline axle, such as this one, measures 1.5 inches. That's quite a difference. The spline shape is significant. OEM axles are manufactured with an involute spline. This means the face of each spline is slightly curved. This provides for an optimum contact patch along with even pressure when engaged. One cannot recreate an involute spline by way of fly cutting, which is resplining. That results in a straight cut spline. To manufacture an involute spline, you must hob the spline. Mark Williams uses an exclusive process to hob the axle splines while in the lathe turning process. The Williams designed hob attachment does the splining process in the same chucking operation as the turning. This produces an extremely accurate spline that is true with the entire shaft. In order for a splined shaft to support maximum torsional load, it is necessary to have a working shaft diameter smaller than the major spline diameter. You can see that here. The reduced section after the spline works in the same way as a torsion bar, allowing the rotational windup to occur over a longer area. This prevents the axle from experiencing permanent set. Axles that are not undercut will twist at the end of the spline engagement, wherever it is falls in your application, and eventually fail at this point. The Mark Williams high torque axle shown here tapers from the axle bearing shoulder down to the minor diameter of the spline. You can see that right here, you can see the taper. This creates a profile in the shape of a triangle. In turn, this triangulation provides the axle with more resistance to bowing. A portion of the axle remains at the minor diameter to allow for torsion bar-like twisting. The triangulated profile prevents it from changing shape permanently. The shoulder of the axle bearing is another consideration. Standard 12-bolt Chevy axles typically have a 1.4-inch bearing ID. Most mid-range performance axles typically make use of a 1.562-inch ID bearing, while the Mark Williams high torque design right here is set up for a 1.774-inch ID bearing. That's a huge difference, especially when you consider that the larger the bearing, the greater the surface area to both carry weight and to transfer the load. As you can see, there's a lot to the custom Ultimate 35 spline 12-bolt Mark Williams builds. The sky's pretty much the limit here, and honestly, everything is over the top when it comes to quality. This is quite likely the strongest iron-cased 12-bolt on the planet, bar none. For more information, contact Mark Williams at the number and/or website address on the screen. When it comes to high performance, drag race, and hot rod tech you can use, stay tuned to Lone Wolf Hot Rod's YouTube channel. And don't forget to subscribe.